What? What could you possibly have a question about? What is my favorite joke? No, no, no. It's a 263 joke. I can't tell it in here. She asked what my favorite joke was. It's a 263 joke. I can't. You know it. Arrays. We're not talking about your grades, Adam. We're talking about arrays. Actually, I've already seen some of you submit today's lab. You weren't supposed to know about arrays, so you were supposed to solve it with if statements. Some people just threw it in an array and then called sort. That's not what I was really looking for, but it does the job. And I might take this opportunity to turn this into a bit of a teachable moment. Even though it wasn't what I intended, it met all the specifications of the project. And if you meet all the specs in industry, you get paid. If they want you to, if they want to tell you how to do it and do it a different way, they need to put that in the spec. So, well done, you. We're going to talk about arrays and better ways to do sorting. Creating arrays, using arrays. They're a little easier, and at the same time, they add more functionality. So we're going to deal with that. Everybody should be familiar with this kind of a notation. We've got a bunch of magical boxes in memory. They're accessed via indexes. This is an array of 5 elements. Anyone who thinks that arrays start at 1, raise your hand. At 1. Get out! Yeah, Lua exists, and so does Scratch, but that doesn't mean it's a good language. Although there's nothing really wrong with Lua. I just prefer Python. So ECE 201. All right. It's a lab course, right? You have resistors, you twist them together, you make voltage dividers. One of Dr. Costa's now graduated grad students was an undergrad, and he wanted to, show how much he knew. So he said, "Professor Costa, does this look right?" And Professor Costa came over, he looked at it, he went, "Oh, that shouldn't be there," and he touched something, and it blew up. Blew up. I think the moral of the story here is arrays start at 0. Because I said so. And my stuff doesn't blow up. Oh, yeah. Hey, Dr. Costa. It's a true story. I'm not saying anything false. Watergate was last lecture where there's a bunch of stuff. Every time I alt-tabbed, there was stuff you shouldn't have been seeing. So if you look at the video, it's like I had to go in and pixelate every single time. There were 8 times I alt-tabbed. I had to go in and pixelate those. All right, so maybe we could just reel back in. An array is a sequence of elements. We have indexes. That's the numerical value of where things are. Then we have the actual data inside of it. The whole thing is an array. But now, an array is more than just a selection of allocated memory. It's actually an object, because everything in C# is an object. So this object has internal state, it has properties, it has fields. One of those properties is, hey, we know the length of the array. Okay. Declaring arrays is very different from C. I say very different, it's slightly different. Instead of saying int my array square brackets, you say int square brackets. The type is integer array. I think this makes a little bit more sense pedagogically. It's an integer array. It's not an int object that is an array. It's an integer array. Makes more sense because that's the name of the object, the type of the object. So anything that you put square brackets after becomes an array, whether it's an int, a date time, a string, a dog class, a pet class, whatever classes we make in the future, anything that's an object can be made into an array of objects. So you would read this, an integer array, my int array, or a string array called my string array. This is, again, a reference type. There are 2 types of variables from last class. maybe 2 classes ago. No, not instance and class. Value and reference types. A value type is allocated on the stack. A reference type has its data allocated on the heap. And arrays are reference types. You have to allocate the data on the heap. The variable myIntArray is a reference to that data on the heap. Yes? Quickly? Very quickly, what's the difference between a stack? A stack has scope inside of a function. A heap is allocated globally. A heap is dynamically allocated at runtime. Things allocated on the stack have like a scope, okay? When you go into a function, you declare a variable that has scope inside that function. When you leave that function, it goes out of scope. That's because it's allocated on the stack, okay? So the reference is allocated on the stack. The data itself allocated on the heap. References you can pass around left, right, and center because they're very tiny. They're a couple of bytes. Data, like the array, could be hundreds of bytes. We don't want to copy hundreds of bytes everywhere we go. We copy the reference. Okay? So the new keyword, once again, new int 5. This is how you allocate an array of 5 integers. You put the 5 in the square brackets. So declaring the variable, you put the square brackets right after the word int. Allocating the data that goes to the reference, you put the number inside of the brackets. Yes?
In practice, do you want us to usually allocate the array? Do you want us to...
Well, if you don't, there's no array, right? This is just a reference. It defaults to null. All reference types default to null. So you have no data on the heap. So yes, in practice, and because it won't work any other way. So you don't have to declare it on the same line as you declare the variable. So there's a difference between declaring a variable and instantiating the variable. That's where you allocate space. Okay, is that what you were asking? Like, do you want to do it at the same time? No, you can allocate it anywhere. It depends on the requirements of the task. Okay? If that's still unclear, we can maybe talk about some specifics. So you have to specify the size, though. Yes? Will this give a reference? So what this does is it allocates memory on the heap, and myIntArray becomes a reference to that area of the heap. This does not allocate any memory on the heap. It just declares a reference. If it helps you to think about it in terms of C, this is a 4-byte pointer that points to nothing. What other one? myIntArray is that right there. Okay, so it's like 2 statements. So you can do it in 2 steps. 1, declare the variable. 2nd, allocate the space. And it has to be a fixed size. This is an array. We'll contrast that later with what we call a list, which is a class that does things. This is an array. Okay. If you don't want to just create a blank array, you can initialize it with a constant array. So this is just an array 1, 2, 3, 4, 5. We don't have to specify the size or the type because it's just typed there, all right, on the line. So you can do that as well. This does a couple of extra steps. Not only does it allocate the memory, but it copies in 1, 2, 3, 4, 5 into index 0, 1, 2, 3, 4, because arrays start at the big goose egg. Yes. I believe so. I might be switching my languages. You can try it. But yes, it just has to evaluate to something. Well, it would have to do it in order. So there's an operator precedence, right? Comma is the last thing in the operator precedence. So it has to evaluate each one of those, whether it goes left to right or right to left. Okay, that's a matter of implementation. Okay, you asked it so quietly I couldn't even hear what you asked, but you were talking to her. That's fine. So you don't have to say new here, but yes, it would evaluate whatever's inside of between those commas. So if you had a function called foo, you could say foo, 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 or fee, fi, fo, fum. Anything that can be evaluated. So you couldn't put something that returned a void, right? But anything that evaluated to a type, you could. Okay. Strings, much simpler than in C. You just put them in. Strings are objects. We know how to handle objects. Objects are old hat. So this is a great way of doing days of week. If I said day of week sub 2, what would that evaluate to? Yes, Wednesday. Took me a second just to count that, but yeah, Wednesday, because the first thing in the list, Monday, is index 0. So Tuesday is 1, Wednesday is 2. Speaking of my Latin teacher, Wednesday was Woden's day. Oh, days of the week. Okay. Ah, look. Anybody want to guess what it's going to print? I hope 7. This just shows you that it does, in fact, run. This is as hard as it is to create arrays. Come on. It's thinking about it. It's trying. There continues to be 7 days in the week. Dot length is what we call a property of the class. So it's not a field, that would be a variable. And there's no variable in there that says 7, but there is a property that evaluates to 7. Array is the name of the class, but this is an instance property. It's not a static property. So it needs the internal state of days of the week. It needs to count how many things are in the array. That's how it gets the 7. Okay? At least I think it's a property. Yes, I can tell that it's a property because of the wrench. Okay? Accessing array elements has nothing to do with surface mount soldering. But it's square brackets. This is old hat. This should be familiar to you. Nothing has changed from C. Index is start at 0 and go to whatever array.length is minus 1. So you cannot say days of week sub arrays of, or days of week dot length. That is beyond the range. And you will actually get an exception that says out of range exception. Let's just modify this ever so slightly. Days of week sub days. I'm not sure it's even going to let me compile this. Okay. It let me compile it. It's going to bring up black screen. System index out of range exception. What happens in C if you try to access something outside the range of the array? It just doesn't. It says, I'm sure you know what you're talking about. We'll just access that location in memory. This has what we call range checking or bounds checking. You can't access outside of the array. So there's a safety check built in. It throws an exception, index out of range.
Would you be able to use that property with the index if you did -1?
Yeah, oh, it would run if you did -1. So we can say length -1. It should give us Sunday. Boop. Sunday. Question. That's an excellent question. I would not seek to guess what the optimizer is going to do. I mean, this all gets compiled down to a common language that's byte codes and things. I don't know. Okay, accessing array elements, fine. An example of reversing an array, just swapping indexes. Not super excited about this one. There's nothing particularly interesting here, but let's do it. So this creates an array with constant values of 1, 2, 3, 4, 5. And actually, this is not necessary, saying new int here. You can say it, and I believe it runs. It's more than happy. Yep, but you do not need that. Except that's still, there we go. If you just do that, it runs exactly the same, because this automatically evaluates to a new thing that gets moved into the heap. So this for loop just creates an array, creates the array of the same size as the first array. This reversed array is allocated using the new keyword, length. Okay, length is itself the array property length. There's a lot of lengths, but we have int length. That creates the size of the reversed array. We then go through and reverse the array. Does anybody need me to explain what's going on here? This is fairly self-explanatory, but okay. And then it prints the array. It iterates over every element in the array, starting at index 0 and going to index length minus 1. Yes? I guess it's just the math that way. It depends on if you think left to right or right to left. Some people prefer to eat the egg starting at the little end, and some people prefer to eat their egg starting at the big end. Wars have been fought over this, I believe. The Lilliputians, Gulliver's Travels, nothing. Little endianness, big end. Thank you. Well, thank you, Tim. Nobody else? Okay. Okay, how do we actually get data in dynamically to an array? Moving on. Input and oh, because it's a connector for a stereo, so it's the input. Anybody know the names of those two cable ends? And the other one? No, it is not coax. Quarter inch, probably quarter inch stereo. Okay, so this is what we really need. We need two pieces of data, or two groups of data. One, the number of elements that we need to input, and then we need those elements. So in this case, we can get a number, n is the size of the array, and we can get n elements by just having a for loop that runs n times. That's it. In this case, we are doing indexed accesses. We're overwriting arrays. So this array had to be declared new int, or had to be instantiated new int of size n. It doesn't have to be a constant number. Anything that evaluates to an integer, which n is an integer, so it evaluates as such. Anything that evaluates to an integer, you can put inside those square brackets. It'll be very happy. It gets evaluated at runtime, not at compile time. In early versions of C, this was not a thing that you could do. You had to have constant size arrays. Read int array from the console and check if it's symmetric. Okay, so this is a little thing that just does something on an array. Checks if it's palindromic, if it's symmetrical around the thing. Not even going to do that. Let's keep going. So printing to the array. Again, we're still using the indexes to access this array. That's going to change in just a couple of slides. But if we have an array, we can use console.writeLine, put the index in, access the individual elements of an array. The only thing that's required is we need to know how big the array is. We access array.length. It's a property. Okay. So, fine. We can iterate over the indexes. But the truth is, there's so much processing that just involves going over every element of an array. This is a little cumbersome. We have to access the array property. We have to keep track of an extra index. And we don't need the index. We just need the data that's in the array variable. So there is another language construct in C# and many other, call it third generation languages, okay, called the for each statement. So we've been using the for statement. Everybody knows what the for is. For, initializer, comparison, update. For each is a little different. So processing using a for, we have to use the index variable. We have to know what the length is, and then we iterate over that. Fine, don't care. For each is a shorthand of iterating over every element in an array. It's safer in a lot of ways because we don't have to worry about accidentally putting our index out of bounds. It knows how many elements there are, and it iterates over each one. The way we use for each is we say for each, and then we say, for example, if we have an array of integers, we would say for each integer val or bob or whatever your variable name is in my array. So we have a type, a value, and then the array that we want to iterate over. So if you don't need to know what the index is, you can use a for each statement to quickly deal with everything in an array. The only downside here is you can't actually change the elements. So it's read-only access. If you try to modify the array while iterating over it, bad things happen. But the for each is a great shorthand. It's a great way of dealing with accessing every element in an array. So here is we all know Sofia is the capital of Bulgaria. The capital of Burkina Faso is Ouagadougou. Speaking of which, Abe, where did you go this weekend? It must have been somewhere exciting. Home? You didn't invite me to your party. I bet you had like 17-layer bean dip and you were watching the Super Bowl on a plasma bigger than my project. No? You didn't watch the Super Bowl? I'll be honest, I didn't watch the Super Bowl. Well, that's what I hear, but I mean, I had the little screen open showing the live score. But I didn't even need to because I knew when they scored because my whole block erupted in riots. When they got that touchdown, then the third quarter, the fourth quarter, whatever it was, screams. I heard it from my basement. But we won, so it doesn't matter. Okay. Processing arrays. So the for each statement, I think it's worth going through this. Okay. I want to put a breakpoint on this line. When we actually iterate over an array, it creates a new variable that only has scope inside that for loop. So I think it's going to do something iterating using indexes, maybe. It's thinking about things. Okay. My poor machine is just having a rough day. Okay. So the variable array has the numbers 0 through 9 in it, in indexes 0 through 9. Should be pretty straightforward. When we say for each, Right now, there is no variable number because we're outside of the for each. As soon as we go into the variable number, every time through the loop is going to take on a new value. Number will first be 0, then 1, then 2, then 3. That's not the index, that's the value. So as I step in here, it says, the array, that's what we're iterating over. We create this integer number. So now, in addition to array, I have number. So the first time through the loop, number is 0. The next time through the loop, number is 1. So there's no indication inside the body of the loop that we're dealing with an array. We're just dealing with a variable called number. It's a slightly different way of thinking about it. We're not accessing an element of an array. We just have this value that's been generated out of the array. We cannot change the number because it's not actually part of the array. We get a copy of what's in the array. So that's why we can't change things. If we tried to say number equals or number plus plus, I don't think it would work. Or it might work but not modify the array. It's read only. Okay? So we run this the whole way. Original array, modified array. Okay, so the way we have to modify it, we have to modify using the old indexed method, using indexers, because you cannot modify the array using for each. Okay, so we use for each to print the array. It's nice and concise. But to modify the array, which here we're just taking every other element, index plus equals 2, every other element, setting it to -1. But both of these print statements are responsible for, are being done by for each statements. Okay, so before we hit the next harder part, for each seems pretty reasonable. Okay, allocating single dimensional arrays, no problem. Doesn't matter what the type is, it's all good. Okay. Multi-dimensional arrays. In C, we could have two-dimensional arrays. We could allocate that. It was all allocated at once. Multi-dimensional arrays in C# are the same thing. They have multiple dimensions. So we have, for a two-dimensional array, you could think of it as a grid. For a three-dimensional array, it would be a cube of data. For 4 dimensions, it becomes a lot of cubes next to each other, or a 4D cube, or a hypercube. It becomes harder to visualize at the 4th dimension. Mostly we deal with two-dimensional arrays. We have a shorthand. We call it a matrix, or if you're an engineer, you call it a table. So we specify it row major format, meaning row comes first, then column. So this is a 2-row, 4-column matrix or table. Everything is 0-based. And this is a matrix of integers. Now we all know what a matrix is. Anybody ever used matrices in math? Don't all look so excited. Okay. Declaring them is pretty much the same as declaring regular single-dimensional arrays. The only thing you have to do is specify the number of dimensions. And the way you specify that is with the number of commas. If you have a single-dimensional array, you put 0 commas. That's space for one number. If you have a 2-dimensional array, you put 1 comma. That's 2 numbers, 1 on either side of the comma. 3 dimensions, 2 commas. First comma, second comma, third comma. I think we can see where this is going. For n dimensions, how many commas must you have? N minus 1. Okay. And when we are allocating space for those, we just put in the numbers. And again, it's major format. So this would be a 3-row, 4-column matrix. That's it. That's how we declare them. So this is different from how we did it in C. This is sort of a new syntax. So it's going to take a little getting used to. But if we want 12 elements, That's 3 by 4. 3 rows, 4 columns each row. Total of 12 elements. How many elements in string cube? 125. 5 cubed. 5 times 5 times 5 is 25 times 5, which is 125. If you want to allocate it statically, I shouldn't say statically. If you want to put it up as a constant, you do it with nested squiggly braces. So the outer squiggly brace is the entire matrix. And then you have a set of squiggly brackets for each row. If you have a 3-dimensional array, you have squiggly brackets. Then you have a set of squiggly brackets that is a matrix, right? So one set of squiggly brackets, that's the matrix, and then a set of squiggly brackets, one for each row. But they all have to be the same size. So if you declare something of size 4 by 4 by 4, everything has to be 4 long. Most consistent list of values. First dimension comes first, second dimension comes next, inside the first. And again, since you're declaring it as a constant, you don't have to specify the size. It's automatically figured out at compile time. So any questions on those two methods of declaring multidimensional and creating constants? Yes? So let's say 5 dimensions. Let's make it 2 by 2 by 2 by 2 by 2 by 2. Sure. Let's 1, 2, 3, 4, 5. That's a 5-dimensional. And you would do something like this, equals squiggly bracket. Now that is the whole 5-dimensional thing. Can we do 4 dimensions? Let's do 4 dimensions. This is going to take a second. So we have 4 dimensions inside of this thing. So there's my first dimension, second dimension, third dimension, fourth dimension. Okay. Inside of these 4 dimensions are 3 dimensions. So inside of this, and let's put some spacing in here so we can see. Inside of this, I have 3 dimensions. 1 dimension, 2 dimensions, 3 dimensions. Inside of each of these, I have another, okay, it's nested. It goes from there. Okay. But that's it. So declaring 4 dimensions, that's like, it requires a little bit of a mind flop. Okay. But you can do it. Let's stick with 2 dimensions for today. Let's all agree that 2 dimensions is a nice number of dimensions. Not as good as 3 dimensions in which we live, but great for tabular data. So, okay. N dimensions we can do. If you wanted to do a 4-dimensional array, you could do 4 nested loops and read in values until the cows came home. But your numbers are increasing by factors, right? So that's a lot of elements. When we start talking about arrays, I'm probably going to have a test that just reads a bunch of numbers from a file. Or I'll like generate random numbers with a known seed so that I don't have to type in a zillion friggin' numbers to test your stuff. Okay, reading from a matrix. This is the important piece right here. This is the difference behind what I've done in the past. Row, comma, column. It's not square brackets row, square brackets column. It's all one object. So the object has this function of square brackets, and it takes 2 parameters, a row and a column. For a 3-dimensional matrix, it would take 3 things. What would we call that? Floor row column or height row column, X, Y, Z, Z, Y, X. Okay. But dealing with 2 dimensions, I think, is fine. So we have 2 dimensions, we have 2 nested for loops. Printing it to the console, no problem here. Note that when we're printing to a console and we're trying to do tabular data, that 4th line is really important. Most of the time we're doing a write with a space after it. So that's column 1, column 2, column 3, column 4. And then we print a new line. Calling write line with no argument just says go to the next line. Okay. The other piece is getLength is a method for multidimensional arrays. That method, you give it what dimension? Dimension 0, dimension 1, all the way up to dimension n. For a two-dimensional, it's 0 and 1. Do you know why it's 0 and 1? Because arrays start at 0. Anyone who says otherwise is selling something. All right. Maybe you might want to look at this on your own time. I'm not going to. I want to get to the good stuff. So the thing about arrays is once you create them of a particular size, they're that size for the lifetime of the program. They don't grow, they don't shrink, they are that size. More often than not, we don't know how many elements an array is going to have when we start the program. Things are a little bit more messy than that. So there is such a thing as a dynamic array. This is an array whose size is not fixed. It's called a list. And a list is your first generic object. It's got scary angle brackets. So it's list bracket T. T is code for type. Any type, int, string, float, can go in place of T. So you can have lists of ints, lists of floats, lists of strings, list of pets, list of students. We resize dynamically. So under the hood, more things are going on. It might be a linked list. It might be reallocating regular arrays. Doesn't really matter to you. The only thing that matters to you is at the end of the day, you can resize them. So they, on the surface, behave like an array. They have an indexer, square brackets, okay, that you can access or modify elements. But you can add array elements. You can remove array elements. So the only thing you need to provide is what type you're holding. Question? Could it cause it to slow down? Anything, if used in excess, will cause the program to slow down, right? If you eat up 18 gigabytes of memory, that's going to be a problem. Oh, like do you mean like you get a cache miss?
Essentially, like, you get this coming in and then wait a while and then here. Does it have to scan through all of them, or is it
Implementation dependent on how it's implemented under the hood. And that's okay. The access times, I think, are guaranteed to be pretty reasonable. Okay. Okay, so when dealing with a list is a dynamic array. We actually have methods that we can use to modify the array. We can add elements onto the end. We can remove elements in the middle. And we can always tell if a variable is an array or a list because they don't represent their size the same way. Nothing is more annoying to me than this fact. If you want to know the size of an array, there's a property called length, or getLength for multidimensional arrays. If you want to know the size of a list, it's called count. Totally mind-boggling that you couldn't just use the same word, length, but it's count. So when we create these lists, these dynamic arrays, we have to say list and then those angle brackets. Those angle brackets tell us what types of data we're holding in this dynamic array. So this is a list of integers, and we use the new keyword just the same. So the type is list of ints. That's how you read that. Those angle brackets, you would say of int. So list of int, called int list, equals a new list of ints with no parameters. We use this constructor to create or allocate this memory, and it allocates some default size, I believe. The difference between the top and the bottom is that one pre-allocates all of the size. So the integer array pre-allocates all 5 things. The list is not guaranteed to pre-allocate. It might have to reallocate as it adds elements. The advantage is you don't need to know how many elements you have at the beginning. For example, if I said read in integer values until you get a -1, you wouldn't want to use an integer array. You would want to use a list, because a list can continue to grow to the limits of memory. Whereas an integer array, you would have to pre-allocate some amount of size. So no matter what size you allocated, I'm sure my test would do that plus 1. So you would be out of luck on that. So this is just highlighting why dynamic arrays are better. If you have one more element that you need to squeeze in, you need to allocate a whole new array, copy all the elements over, and then you can put that last element in. With dynamic arrays, you just add a new value. It's taken care of in the background. Okay? So much of the object-oriented paradigm, silly word, paradigm, is encapsulating the data. You don't know how this is implemented under the hood, as it were. You just know that it's going to put that value in. You're guaranteed that the value is going to be there. It's not going to die and disappear off into the ether. Hopefully, whoever implemented this library didn't cause memory leaks. It just is going to run. So let's talk about this guy. So here we have a couple of bros, and we're going to print, or we're going to add those bros from a array to a list. So we're taking it out of arrays, we're iterating using for each, and we're using the add method for list of strings. So list of strings is a list of strings, go figure, descriptive variable names for the win. But when we say list of strings dot, there's a whole host of things we can do. We've only seen add, but if you look, you can add a range of variables, so you can take a whole array and stick it in. We can clear the array, basically get rid of everything in it. There are some really helpful features, like we could do a binary search. That's actually one step above just a regular search, because it doesn't just find the element, it tells us how it's going to find the element by subdividing. The property capacity is different from the property count. Count is how many elements there are. Capacity is how many elements there could be before something has to be reallocated. So typically you'll start with maybe this much allocated, and then you'll slowly fill that in. Once you get to the point where you need more, it will allocate probably double that. Okay? So you can actually start this with a known capacity. Say you know about 30 elements are going to be there. So you can say 30. It will automatically start at 30 capacity, but count will still be 0. All right, so here we go. Run this guy. What is, oh, .add. Is this like, oh dear God, what is my machine doing? No, it's using the software, no, CPU 8%. What is, there's nothing here. We don't have a lot of time left, so I can't, there's nothing here. There's straight up nothing. RTF track? Oh, that looks like fun. Okay. Yeah. Okay. So the output isn't all that interesting. It's how the output generates it. It's using a for each over a list. Okay. It doesn't matter whether you're using a list of strings. You can use for each for either an array or a dynamic array, a list, and it's very happy. Okay, copying arrays. So we know that things are allocated on the heap for reference types. When you use equals, sometimes you are just copying references, which is what we call a shallow copy. So say you allocate 10 bytes on the heap. You have a reference to that. If you want to copy that data to a new thing, you need to allocate another 10 bytes. You can obviously do that by iterating over, creating new arrays, but the array copy function, this is a static method of the array class. This will work for either lists or arrays. This is a shorthand for moving that. We call that a deep copy. So there's a difference between shallow copy and deep copy. Shallow copy is what we call it when we only move references around. And a lot of times we want to do that. We just want to move a reference. And we can have multiple things pointing to the same data on the heap. But there are times where we want to create a whole copy of the entire data structure, the whole array, the whole class. It's important to use something that does a deep copy, because consider for a moment I have one object on the heap and I have two references pointing to it. Let's call it A and B. If I say A sub 5 equals 10, and then I query B sub 5, B sub 5 will be 10, because I changed it through another reference. So even though it looks like A and B are separate variables, they are references to the same thing. That is bad news. We want to use array.copy. Okay. No homework tonight. New lab has been sent to everybody. Has everybody not gotten a lab? That was not a question that made sense. Is there anyone who has not gotten the link to this week's lab? You have not gotten it. Come up and see me after class. Let's make sure that you get that email. Okay. Question. Labs are due right before the next lab. Yes.